Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to my 2D hack and slash course. This is going to be lesson 3, and in this video, we're going to be animating the character as they move, and we're going to start introducing some kind of wall objects as well, some solid objects that the character can't move through. So let's get started. Very first, we're going to introduce the animation. Currently, we have our sprite set to skeleton, skeleton idle. So the way that you can change while your game is running, so this is how you can change what sprite is assigned to this object while your game is running. So we'll just say sprite index equals s skeleton run. Right here, and then put a semicolon. So sprite index is whatever sprite is assigned to your current object. So we're saying assign, this is the assignment operator, assign our skeleton run sprite to our sprite index of this object. Now if we run our game, our character will do the run sprite, but we have that weird flipping again. And he's always running even when we're standing still. So that's not what we want. Let's come into our sprites and let's come into our idle and kind of see where we put this. Put it at the bottom over 24 from the X. So if we come into our run, it's going to be similar. I think they're the same size. So we'll do the bottom here on our Y, so 48. And 24 on the X. That should give us a similar position. And we'll test that and see if that looks pretty good while we're running. And now we're flipping. That looks much better when we switch directions. So let's come back to our object. And inside of here, we want to, in the same way that we made it so that the character only moves when you're pressing one of the keyboard keys, we can also make it so that it only sets the sprite to the running sprite when we're pressing one of the keyboard keys. So we'll just copy this code. I'm going to do Control X, and we can paste it into both of these places right here. And if we run our game in this state, you'll see that now when we start off, we're in our idle. And then when we switch to running, it switches to the run. But it doesn't switch back to the idle. That's because we never have a place here where our code switches back to the idling. So one of the ways that we can do this is we can have a line inside of here, outside of our if statements, at the very top. You want it to be at the top, or else this, and let me show you why. Instead of just telling you, I'm going to show you. So let's say we do it out here. What if we just say, okay, outside of our if statements, we'll set it back to s skeleton idle. What if we do that? Okay, now our running doesn't work anymore. Why is that? Why? We're switching to the running sprite right here when we press the keyboard key. Well, the problem here is that code order is very important. So GameMaker comes and it steps through each of these lines of code in order. So if you kind of think this through in order logically, we come down, we say if we're pressing the right key, come in here, set our skeleton to the skeleton run. That's great, right? Because we're pressing the right key, so we want them to run to the right. However, it continues to step down this code, and it sees this part and it says, oh, change it back to the idle. And it just does this all the time, but it's doing it after we set it to run. So the problem here is that we're setting it to the run sprite, but then immediately after, in the same frame of the game, this all happens in the same exact frame. So in the same frame, we set it back to idle, even if we set it to run. And that's not what we want. But if we change the order here, if I do Control X again and paste this up here at the top, what's it going to do? It's going to say every frame set us to the idle frame. Great. You know, if we were previously in the run, that's fine because we want to be in the idle frame. Then we step down through the code in order and we say, oh, we're pressing the right key. Set us to the run sprite. Set us to the run sprite. And so then it will set us to the run. But if we're not, then it just leaves it as the idle. So order here is really important because we need to set it to idle first because that's kind of like our base state. It's like idling is when we're not doing anything. So just do that by default. Set us to idle. Assume that we're not doing anything. Then we check to see if we are doing something and change sprites accordingly if we are. So let's run it this way and you'll see that it should work now. We have working code here. This obviously isn't going to work all the time though. If you'll notice, it doesn't complete the animation. And that is because I think these have different frame counts. So then even though we're setting it to this, if we set it to this first, we're never able to complete our frame count. So there's an issue with this system as well. So one other solution is to write some new code here. Let's get rid of this. And where we do this is less important, but you can say, we can use a new term here. We can say if not keyboard check VK right and not keyboard check VK left. And I promised I was going to try and do brackets like this to make it easier for beginners. Set our sprite index equal to sskeleton idle. So now what we're doing is we're basically only setting our idle frame if we're not pressing either of these keys. So if we're not pressing the right key and we're not pressing the left key, set us to the idle state. And now we can complete our run animation, but we also switch back. The other benefit of this is we can then set how fast the image animates. So we initially set our image speed to 0.4, but when we're running, that doesn't look very good. So we can set in here in the run, we can say image speed equals 0.6 maybe. And you can set this in both of these checks right here. And then down here on our final check, we'll set it back to 0.4, which made sense for the idle. It looked the best when we were idling. So now we'll have some different animation speeds based on what we're doing. Running is a little bit faster animated than idling. Awesome. Now let's set up our collisions with our wall. So we're going to create a new object here. And we can just right click on objects and we'll name this O underscore, well, you can call it, we'll just call it wall. And we'll add, well, we don't have to add a new event to this, but we do need to give it some sort of a sprite. And if I can open up my resources here. I'm going to open them up on the other screen. But in your resources, you'll have a sprite, grave resources here, found them. Inside of environment, you'll have a sprite called swall. You can just drag that sprite, drop it into sprites right here. Now we have swall, created this for us. And we can scroll down, click on our wall object, and assign swall to it. Now we can place this object inside of our room. So come into your room, inside of rooms, and we can place, click and drag that object and place one right here and one right here for now. Okay. And run the game. So we've created our wall object, we've put some in the room. Now if we move towards this wall object, we move right through it. So it's not actually doing anything yet. We haven't fixed anything. So how do we fix this? How do we fix this so that we can't move through our wall object? Well, our code needs a little bit more work here. We need to be able to handle cases where there's a wall in the way, because we're just checking if we're pressing the right key. We're not checking to see if there's actually a wall in the way at any of these points. So the way that we can do that is with a function called placeMeeting. So let's do to the right first. And we'll just say if keyboard check vk right and not play. Let's see. So you can do this as the not. Remember how we wrote not down here? You can also do this symbol, an exclamation point. Well, I'm going to write it out though. And not place meeting X. Okay, so let's look at place meeting here before I just get writing code. So place meeting, you can look it up in the help by middle clicking on it. And you can see we need to pass in an X position and a Y position and an object. So the X position to check, the Y position to check, and the instance or object to check for. And here we get some examples. So place meeting returns true as one or both of the instances. Well, this is talking about precision, collision precision, but just use this as an example. So we've got our object right here, and we imagine that it's moved to this location right here. And that's the X and Y position that we pass in for. And then we're checking for this coin object. So that would be the object we'd pass in. So are we colliding with this coin? Well, at this position, yes, we would be colliding with that coin. So this function will then return true. However, if we check this position right here, our object wouldn't be colliding with any coins and it would return false. So inside of our code, we can just say place meeting X, so our current X position, plus 4, because that's where we want to move to. So we're going to say check the same distance that we want to actually move. So X plus 4, and then our Y position will be the same because our Y position won't change at all. And then the object we want to check for is O_wall. Okay. So and not place meeting X plus 4 O_wall. Let's run the game. And you can see now we no longer move through that wall. But we still move through the wall to the left. But then if we try and move to the right, we can't move to the right because there's a wall in the way. So we get stuck inside of that wall. So we're going to do a mini challenge here. I'm going to challenge you to write your own place meeting code for going left right here. So pause your video and see if you can write the code to check for moving to the left for a wall. Okay. If you were able to do that, great. If not, I'm going to show you how to do it. We'll do and not place meeting X, and then we want to use -4 here because we're subtracting 4. So that's the new direction we need to check is to the negative. Our Y will stay the same, and we'll check for object wall here as well. Sweet. Now when we run the game, if we move to the left, we stop at the wall. However, if we tap to the left and we kind of move, we can kind of get stuck in the wall. Now, why is that? Why are we getting stuck in this wall? That's annoying, right? This is a really common issue. So common that this is probably one of the most important videos in this course, for beginners, I should say, which is collision masks and issues with collision masks. Now let's talk about what's what's happening here real quick. So if you come to your sprite and you look at your idle sprite, if you come down here, there's a collision mask option. And if we click on this collision mask option, it's going to show us the collision size for this sprite. And GameMaker has automatically assigned a rectangle to it. And this is the collision for this image right here. Okay, let's look at our run now. And let's look at the collision mask for the run. Now, if you'll notice, these are different sizes. The collision mask for our run is wider and bigger than the collision mask for our idle. So when we change sprites, it actually changes the size of our collision, which is bad. Because when we run the game right here, you can see we're running to the left and we can't get any closer because our collision box is hitting the wall, right? However, if we let off, all of a sudden it switches to our idle animation and we can get a little bit closer because our idle animation has a smaller collision box. So we can get closer. But then if we try and move to the left, we're actually inside the wall. And so we can't move anymore in that other direction because even if we move over 4 pixels, we're still inside the wall, so it still won't let us move. Now you could make your collision boxes the same by setting your mode to custom and setting these so they would be exactly the same, but that gets tricky and tedious. Every time you add a new sprite to your character, you need to create a new collision mask and make sure that it matches your other collision masks. Huge pain. Not what you want to do most of the time. There might be cases where that's okay, but this case, definitely not. So, what can we do? If you look over at our skeleton right here, you can see I have an S skeleton mask. And it's just this sprite right here. Now this mask is designed specifically for our skeleton. And if you come into your collision mask, you can't see it because it's black, but basically the collision mask here is the exact same size as this rectangle. Now, in our object for our skeleton, there's an option right here for a collision mask, and currently it's set to same as sprite. So whatever sprite it's set to, it'll be the same as that. Well, we can actually assign this sprite right here to be the collision mask for our skeleton object. So we click here on the collision mask, and we go to skeleton, and we select this S skeleton mask. Now, we're going to have issues here because of our origin. If you see our origins here in the top left-hand corner. Well, for our skeleton, we actually want it to be in the bottom center, like this. Because that's how our skeleton sprites are set, right? So, let me zoom out just a bit here. Get rid of this sprite. Okay, zoom in just a bit, and you can see the origin on this sprite. If I unclick collision mask, our origin's down at the bottom, so the origin on this needs to be down at the bottom as well. That way, if you imagine this right here overlapping our current sprite, it would overlap it somewhere right here, and that would be the collision for this skeleton. Now, the biggest benefit of this is that you know that your collision mask will never change. And that helps prevent your character from getting stuck inside walls. So now, no matter what we do, we can't get stuck in this wall anymore. And our collision mask is working great. So now you've got movement with animation, and you've got collision walls. That's going to be it for this lecture. In the next lecture, we'll start talking about the different states for our character so that we can transition into attacking and rolling and stuff like that. So thank you guys for watching this video. Hopefully you enjoyed it, and I will see you guys in the next one.